Good morning everyone. How are you all? So I hope all are doing good. So today we are going to learn about the brief review of black body and the postulates of Planck's quantum theory of radiation. Okay. So first of all, what is black body? Can anybody know what is black body? So black body means it is a perfectly absorber and perfectly emitted the radiation. Means here whatever the radiation incident on a black body, it completely absorbs, and whatever the radiation the black body absorbs, the complete radiation of the black body emitted. So this is what the procedure of the black body. For example, if I take the halosphere shaped body, this is what my halosphere shaped body containing a single hole here, for example. Okay, this is what my halosphere. Okay, this halosphere consisting of a single hole at one end. Okay, and next, if I incident, for example, this halosphere inside of this body is coated with a lamp black. Lamp black means what? Deepapu masi. Okay, so inside of this body is coated with a lamp black. Okay, I coated with this inside of this halosphere with lamp black. Then now I would like to introduce the radiation inside of the black body. Okay, this is what my radiation, incident radiation. Okay, whenever the radiation enters into this halosphere, what will happen? It will reflects. Means the entire radiation reflects in a different directions, and finally the radiation, whatever the radiation entered into this halosphere, the complete radiation absorbed by this lamp black. No radiation coming outside of this halosphere. This is what here lamp black is acting like a black body, because whatever the radiation incident on this lamp black, the entire radiation is absorbed by this lamp black. So that is why it is called black body. And also whatever the complete radiation absorbed by the black body, it completely emits. Okay, it completely emits. This is what about the black body. And one more thing about this black body is there is no such perfect black body is existed in this universe. Okay, no such perfectly black body, perfectly emitted or perfectly absorbed black body is not existed in this nature. Okay, but lamp black, it is almost acting like a black body, but not exactly. It is not exactly as a black body, but almost nearer to the black body. Okay, now coming to the postulates. What are the postulates of quantum theory of radiation? Planck's quantum theory of radiation. Okay, Nana. So postulates of Planck's quantum theory of radiation. So according to Planck's, he has given some postulates. So what are those? According to Planck's, the emission of radiation. So whatever the radiation emitted by the black body, it is purely because of vibration of charged particles inside of the body. For example, this is a black body. So for example, if this black body emitted radiation, okay, for example, this black body emitted some kind of radiation. Yes. So this radiation is completely because of the charged particles. Okay. Because of the vibrations of the charged particles inside of the body. According to Planck's. Planck saying చెప్తున్నాడు, only because of the vibration of charged particles only the emitted radiation is possible. So this is what our first postulate. Now coming to the second one, a black body radiator contains simple harmonic oscillators. So here whatever the black body radiation, this contains simple harmonic oscillators, and each simple harmonic oscillator of all possible frequencies. Okay, all possible frequencies. Okay, according to these assumptions, all these postulates only according to Planck's first of all, the first postulates of Planck is the emitted radiation only because of the vibrations of the charged particles inside of the black body. And next one is what, Nana? The simple harmonic oscillators. The black body radiator contains simple harmonic oscillators with all possible frequencies. Okay, with all possible frequencies. And the third one is the emission of radiation. Here the emission of radiation is not continuous process, it is a discrete process. So why? Because it is a discrete process. It is a discrete process, and this discrete nature is in the packets, is in the form of packets of energy. These packets of energy is called quanta. Already we have learned this in our third semester, I think, quantum theory of radiation, Planck's radiation law. So according to Planck's law only, these are all the assumptions. Okay, the energy is not continuous, the energy is a discrete. So this discrete energy is in the form of packets of energy. These packets of energy is called quanta. Already I told you, for example, if you go to the shop, then if you want to buy 4x or 5x, nobody can buy 0.5 egg or 1.5 egg. Everybody can buy or 1 egg or 2 egg. Means all the integral values of the x. Means the integer value can only exist. Like that, the quanta. Here half quanta, 0.5 quanta, means both are same. 1.5 quanta not exist. 1 quanta or 2 quanta or 3 quanta. Means all the integer values are possible here. Okay. So this is what about the packets of energy. Okay, the packets of energy is called quanta. And next, fourth one is the energy associated with each quantum of the particular radiation of frequency is given by. Here the energy associated with each quanta is called E is equals to h nu. Okay, each quantum of energy is represented by energy is equals to h nu. E is equals to h nu. But already we know that for an oscillation we are having, for an oscillator of a frequency nu, the possible values of energies, okay, the possible values of energy E is equals to n h nu, where n starts with 0, 1, 2, 3, all the integer values. Okay, here for the oscillator of frequency nu. Okay, so there are many number of possible frequencies are there according to Planck. So that is why here he introduced the value n. E is equals to n h nu. N may be 0, n may be 1, n may be 2, up to so on infinity values. Okay, in this case. Now the emitted radiation propagates in the form of waves. The emitted radiation is in the form of propagates. Okay, so according to Planck, the emitted radiation propagates in the form of waves. So that is why each oscillation contains a frequency and the total energy can be represented as n h nu. Here n is equals to 0, 1, 2, 3. For example, there are n number of quantum harmonic oscillators, that is n number of Planck's oscillators. Okay, for example, let n be the total number of oscillators. Okay, total number of, okay, so capital N be the total number of Planck's oscillators and capital E be the total energy. Okay, total energy, I am writing TA simply. Then what is the average energy per Planck's oscillator? The average energy E bar is the average energy, can be represented as E by N, means total energy by total number of Planck's oscillators. If you divide total energy with the total number of Planck's oscillators, you will get the average energy. But already we know that there are n number of oscillators. So here N0, N1, N2, N3, up to so on NR. So these are the oscillators. Okay, these are the oscillators. These oscillators having energy 0, E, 2E, 3E, up to so on RE correspondingly. The corresponding energies of oscillators are 0, E, 2E, 3E, 4E, up to so on RE, okay, respectively. Then what will happen? Here the total number of oscillators can be represented as N0 plus N1 plus N2 plus N3 plus up to so on NR. Okay, but what is the total energy here? The total energy can be, here the energy can be represented as, total energy can be represented as multiplication of energy, multiplication of corresponding energy with the number of oscillators, that is 0 into N0 plus E into Na, E into N1 plus 2E into N2 plus 3E into N3 up to so on Re into Nr. Okay, this is what the last value. So now if you just simplify this equation, 0 into N0 means what? 0. Okay, now it is N1E plus 2N2E plus 3N3E plus up to so on Rnre. Okay, so here let us consider this as equation number 1. Okay, let us consider this as equation number 2. Now already I told you, according to Maxwell's distribution law, Nr is equals to N0 into e to the power of minus Re by kt. Okay, let us consider this as equation number 3. Nr is equals to what, Nana? N0 into e to the power of minus Re by kt. Okay, now what is the value of N1 from the above equation? N1 is N0 into e to the power of minus e by kt. What is the value of N2? N2 is equals to N0 into e to the power of minus 2e by kt. What is the value of N3? N3 is equals to N0 into e to the power of minus 3e by kt up to so on Nr value. This is what final value. Okay, now you substitute the values here, N1, N2, N3. Already we are having N1, N2, N3 here. Okay, substitute all these values in the equation number 2. What you will get? Substitute it. Okay, so after substituting in this equation, this is the final. This is N1 is equals to N0 into e to the power of minus e by kt plus 2e into N2 is equals to N0 into e to the power of minus 2e by kt plus 3e into N3 value is what? N0 into e to the power of minus 3e by kt. Okay, now simplification. In this all these terms, N0 is a common term, and also what is the common term here? E is also common term. So take the common values outside. What you will get? E is equals to, okay, so in this equation E is a common term, and next N0 is also common term, and also in each equation there is a common term, that is e to the power of minus e by kt. Okay, this is a common term. Then what is left over here? It is 1 plus here 2 into e to the power of minus e by kt. Okay, 1 plus 2 into e to the power of minus e by kt plus here 3 into e to the power of minus 2 into e by kt, because 1 e by kt gets cancelled. Okay, plus up to so on. Okay, so this is the equation. So now see here, this is in the form of 1 plus 2x plus 3 into x square. Okay, this is what? E to the power of minus e by kt whole square. Okay, 1 plus 2x plus 3x square plus up to so on value is what, Nana? 1 minus x whole to the power of minus 2. Okay, here x value is what? E to the power of minus e by kt. Here x value is what? 1 minus e to the power of minus e by kt. Okay, so substitute this value in this equation. So e is equals to, this e is different from this e, don't cancel both of them. That is why you can differentiate this e from this e. Okay, e N0 e to the power of minus e by kt, it is 1 minus x means e to the power of minus e by kt whole to the power of minus 2. Okay, I can also write this N0 e to the power of minus e by kt divided by 1 minus e to the power of minus e by kt whole square. This is what? The energy. Now I would like to calculate the total number of oscillators, that is capital N. Okay, okay, here already we are having the value of E. Okay, we are already having the value of E. Now I am going to calculate the value of N. So for calculating the value of N, you have to substitute the values of N1, N2, N3. Okay, from this equation N1, N2, N3, substitute in this equation. Okay, okay, after substituting the values of N1, N2, N3, so this is the equation. So now take N0 as a common, because N0 is common in each and every term. So N0 common, after that it is 1 plus here it is e to the power of minus e by kt plus here it is e to the power of minus 2e by kt plus e to the power of minus 3e by kt up to so on. So next n0 is a common term, 1 is as it is, so e to the power of minus e by kt is also as it is. Can I write this term as e to the power of minus e by kt whole square? Yes. Plus e to the power of minus e by kt whole cube? Yes, up to so on. So this equation is like 1 plus x square plus x cube plus up to so on. So what is its value? 1 plus x whole inverse. It is value is 1 minus, because here it is plus terms, no, it is 1 minus x whole inverse. 1 minus x whole inverse value is 1 plus x square plus x cube. Now it is substitute. Here x value is what? No, e to the power of minus e by kt. Okay, substitute this value in this equation. Here n is equals to n naught into 1 minus x means e to the power of minus e by kt whole inverse. Okay, n is equals to n naught into 1 minus e to the power of minus e by kt whole inverse. Okay, this is the value of n, this is the value of e. Substitute e and n in the average energy, you will get the average energy formula. Okay.